Hi, this is Josh with Linux. We're going to go over changing Sally's password. So the prompt is going to be sudo, because we have to elevate that one, password, and for Sally. New password is going to be PRMLND 2003 exclamation mark. So PRMLND 2023 exclamation point, enter, and then PRMLND 2023 exclamation mark, and it's been updated successfully. Okay, now we're going to verify the logon for Sally. So we're going to go super user, Sally, password, PRMLND 2023 exclamation point. Now let's see if that actually switched over. So we're going to do who am I? And it shows we're logged in under Sally. Bruce, Phil, and Doug no longer have access to engineering group. Determine 2 or 3 reasons why this could be and make a note of each. So one of the reasons would be if for some reason the group was changed and they don't have access to it. One way we can look at that too would be cat etc group. And we can see right in the middle there, engineering group 1004 is Bruce, Phil, and Doug, so they are part of the group. So we're good there. Another thing that they can lose access with is a group password. So now that we have a password set for quality assurance, we're going to see if Tim has access. So just kind of verify how everything looks here. We're going to do get int and group. So we can see there we got Tim, who is part of quality assurance. Let's try actually doing, we're going to do cat etc g shadow. So that way we can see that there is a password set for the quality assurance. There's a hashed password, and Tim is part of that group. So now we can actually see both. All right. So now let's try to access something under Tim. So we're going to switch users to Tim, and just so we can verify we are Tim. There we go. And we're going to kind of go ls, oops, la. Let's see what we got here. So this is what we have access to. Under Tim is we have access to a folder that I created that's QA. So that's the only access he's got. And now we can actually see the QA in the middle. Group access is for quality assurance, the only one that's got access to that for read write. So we have the original user and group, and execute for everyone else. I'm going to get rid of that. But just for the sake of testing it, we're going to do this. We're going to go nano QA test txt. There we go. And the file already has you have access. So we have access to it, but can we write to it? So we're going to do I do have access to write this. So we're going to exit out. We're going to save it. No errors. Now if we go back in it, QA test txt. There you go. Saves the file. So he's got permission to write. So now we're going to show hardware info after installing it. We're going to go HW info, and we're going to get the short list of that, and we're going to pipe that into less, so that way we can actually manipulate the list. So we're going to let that run. All right, here's our list. We have our CPU, keyboard, mouse, sound storage, network cards, disk, all that jazz. All right, and then it's going to ask, that displays the hardware from our virtual machine using HW info to display the information about our CPU. We can do that a couple different ways. So we have our CPU information there at the top. We can also quit out of that, and we can do HW info CPU, or we can do CPU less. And we can kind of go through and actually see more detailed information on our CPU. After installing, we're going to do the ls dev command. This is going to show all our I/O ports. So if we need to know what an exact port was for a particular device, like our PCI bus or the keyboard, this will list all the I/O ports for our devices on our computer. What directories are found in the /sys directory? Why are they needed as part of the system? Sys directory directly interacts with the kernel. So if we want to see how certain settings are set, we're going to change directory to sys so we can see what's going on here. And we have several directories as far as bus, class, devices, firmware, hypervisor, kernel. So like things like your MAC address for your NIC card, the brightness of your screen, everything's kind of set in this folder. And we can either inquire or make changes through here. But it's more of just how the user interacts with the kernel. Okay, we're going to look at the ps aux command, and we'll pipe this into less because there is a lot of stuff in here. So all our system processes, we can see what user, what PID, and what command is running. So we can actually see here we have whether it's running or not, what ID it is. So we have a process in here that needs to be killed. That's a good way for us to find it. Step number 10 here, what the permissions for Ted and Doug are to the data1 directory from week 3. So we're going to go back to here. We're going to log into Ted. So we're going to go to our mount data one. Oops. Actually, we're going to go back one. And we're going to do LSL. Looks like for the it's root is the owner and root is the owner for it. So everyone else are going to be the last three. So we have read and execute for that folder, and same is going to be for the duck. All right, we're going to go over to step 11 using set facl to give Sally read, write, execute to data one directory. So we're going to go back and we're going to see where we're at now. So we're in the mount directory. So we're going to LSL. We're going to see what the permissions are at this moment. So what we're going to do is we're going to do set facl, modify user Sally. And we're going to give her read, write, execute explicitly. And we're going to do that to the data one directory. All right, so now we're going to go back, and we're going to see we get a little plus sign just to the right of the X, and that's going to give us, means that there is explicit permissions for that folder that we added for Sally. And get facl to data one. And we see user Sally's got read, write, execute access. And why is it important to troubleshoot and solve problems in Linux? Number one thing is a lot of containerization is done in Linux because of speed. It requires less resources and operates faster, so there's a lot of containers and cloud resources that run on Linux. Two, identify and provide three things that you would suggest to management as they consider upgrades in the future. First things first is always going to be hardware compatibility. You want to make sure any kind of upgrades are not going to create system issues. That's going to be our number one go-to. Two is test in a sandbox environment. If we do any kind of upgrades, we want to make sure that we test that in an isolated environment, make sure we don't have any issues before rolling it forward. And once we do roll it forward, have a backup plan. So if we do bump into issues, we have a way to revert back to its original state.